This is Gail Kovac with Gresham Barlow School District, Summer School, High School Credit Recovery, Algebra 1A, and Learning Target number 4. I can solve and graph compound inequalities. In target number 3, we solved inequalities, kind of like solving an equation, but your answer is a set of numbers, not just one answer. And in this case, we're going to be doing something very similar, but we're going to be doing two at the same time, either an and inequality or an or inequality. So for this and inequality, we are looking for a solution set, a set of numbers that will satisfy this inequality and this inequality at the same time. So there's going to be some overlap. In this one, we're looking for values of n that would work for either this inequality or this one. So any of the numbers that satisfy either are going to work. So we're going to have a bigger range of values available for this one. So let's start. This is basically two inequalities in one. And what we're going to do is solve each of them separately, graph both of their solution sets here, and then see where our overlap is. So let's start with the one on the left. I'll do this one in purple. So just like solving equations, I'm going to do the same thing to each side to isolate the variable x. In this case, this is just one step. To get rid of this minus 2, I'm going to add 2 to each side. And I've got additive opposites of plus 2 and minus 2, so now x will be all that's left here. X will be all values that are greater than. Negative 11 plus 2 is negative 9. So that's 1, and we can graph that here. So this is strictly greater than, so I'm going to have an open circle on negative 9 over here. This is x is greater than, so all my answers are going to be pointing over to the right. These are all the numbers that are greater than negative 9 all the way up to positive infinity. So that's 1. Now let's do the other one. So in this case, I've got all values that have been divided by 6. I need to undo that divide by 6. Remember, a fraction bar is just divide. I mean, look at it. Division symbol is kind of like a blank fraction with dots instead of numbers. So this means x divided by 6. To undo that, I'm going to multiply each side by 6. And divide by 6 and multiply by 6 are opposites and cancel. Here I will have x less than or equal to 1 times 6 is 6. So let's graph that inequality now. So it's all values that are less than or equal to 6. So here's my target value of 6. 6 is included as a possible solution here since it says or equal to. And then I'll be graphing less than, which is over to the left, pointing this way. So here's these ones. So let's see now where these overlap. You can see that I have a double shaded region right here from here to here. Let's express that on its own sort of number line, and I'll just kind of fake this above. So it starts here at negative 9, and then it goes all the way up to and including positive 6. So if on the number line you just want to draw this, you can do that. If you want to leave it as a double shaded region, just circle that. I mean, I'm fine with that. You can also express this as a compound inequality. All my values of x, the numbers that x are allowed to be, are in between negative 9 and 6. So here's all my answers of x. They're between 6 and negative 9. Now it does include 6, so I'm going to have an or equal to sign under here, but not for this one. That's an open circle. It's got to be greater than negative 9. So x has to be less than or equal to 6, but negative 9 needs to be less than my answers. So notice here that this is essentially equivalent to the inequality we have here. And this one is essentially equivalent, however, it's just flipped around from this one here. Instead of x greater than negative 9, we've got negative 9 less than x. So these arrows are always going to be pointing in the same direction for your values in between here. So you can express your answer like this if it is in inequality form that they want, or graphing it like this. So now let's try the OR. In this case, we've got values that satisfy n in this one or this one included in a solution set. So let's try the first one. I'm going to isolate the value, the variable n here by getting rid of this -6. I will do the opposite, which is add 6, and I will do that to both sides. +6 and -6 are opposites and cancel. I'll be left with just n, and that will be greater than or equal to -3 + 6 is 3. So let's graph that one. My target value is 3. That's here. I have an or equal to sign, so I'm going to fill that in. And it's all values that are greater than. So greater than is in this direction here. So there's one solution set. Let's do the other one. All right. This is n with a coefficient of 2. Multiplication is implied, so I'm not going to subtract 2. The opposite of multiply is divide. I'm going to divide each side by 2, divide by 2, divide by 2. Multiply by 2 and divide by 2 are opposites and cancel. N will be less than or equal to -16 divided by 2 is -8. So let's graph this one now. My target value is -8. -8 is a possible solution since it says or less or equal to. And this says all numbers that are less than -8. It's pointing in this direction, so that's going to be these values right here. Notice in this case, there's no overlap, but both this and this are solutions at the same time because it just has to satisfy one or the other. It can't satisfy both. You can't have a value that is in this section and in this section at the same time. You can have one that is, however, in this one or this one. So we can express our answers just like how we did here with our target value of +3, and this one here of -8. And your solution set you can just write as the two separate pieces, or n. Oops, I did it the wrong way. Let's erase that. N has got to be less than or equal to -8, or n has got to be greater than or equal to 3. So you can express it just like this. It's going to be separated, not together like this one was because there was no in between. It was either this piece or this piece, and graph it like this. So to remember here, solve each one separately, but graph them together. If you got an overlap with an and, then that's your solution set. If it's an or, it'll be anywhere that you have shaded all combined.